All right, well, hello everyone, and welcome to the first workshop in our Python workshop series. My name is Jeffrey, and I am one of your hosts, I guess.
Yes, and I'm Marlene Salazar, and I will be the co-host.
And today we'll be going pretty much over the basics. Basics of programming, basics of Python, some pretty simple stuff, like for those of y'all that haven't programmed before, we're just going over basic stuff. We're going to go over the introduction to Python 3. We're going to go over different IDEs just for programming, basic input and output, commenting, variables, data types, and basic arithmetic and math.
Yes. Okay, so why Python? So Python is one of the most fast-growing and very popular programming language. As you can see here on the side, a lot of platforms and systems uses Python, such as Google, YouTube, Dropbox, Netflix. So many more other companies use Python. And it's also a very easy language, programming language, and it's like a really easy one to start off. I know like C++ and all that, they do require a lot of like semicolons, but this is just very basic and to the point. It also has many extra libraries and free ones and built-in packages, and you can also download more on the site if you wanted, such as OpenCV. It is free and it works with Python. So an integrated development environment, so an IDE. So what an IDE is, it's an application used to help in writing code. It makes your writing your code easier. So here we have some examples of Visual Studio's, Notepad, and Eclipse. If you're a Mac user, instead of Notepad++, you can use Text Wrangler. But yeah, so these applications basically just make the executing files and also fixes your syntax. Syntax is just the programming language grammar, you can say. And then you can also, within these applications, change the personalized look. Like Visual Studios, you can do like night mode or light mode. But there's so many more other integrated development environments. There's like Spider with the Y and PyCharm. But we won't be using a downloaded one. We will be using an online version. So the one we'll be using is Google Colab. It's an online IDE, so you don't have to download it, and it has an integrated compiler. You don't need like a powerful computer. You really just need like Wi-Fi. And then it allows multiple people to work on it also. So that's the great thing about Google Colab. There's they just show you like demonstrating certain block, as you can see like in the picture here. It shows you like certain blocks of code that you can do. And Google Colab helps you write code for like AI projects, facial recognition, and it's for free. And if you had like an IDE download onto your computer, you can have these libraries, but you have to download them separately. And then there's other different online ones. There's like online GDB. And if you're interested in other ones, you can join our Discord, and we have like a list of them on there. And Jeffrey will show you around on Google Colab.
So one major thing about Google Colab is like pretty much you don't need a powerful computer. Everything you do on Google Colab is running off of some powerful computer like way off, I don't know, in California, something like that. So you don't need a powerful computer, and has many free libraries for you to use. Like some to note are NumPy, which is basically more stuff with like arrays, numbers, stuff like that. We'll go over that in a future workshop. You got OpenCV, which is, here we go. OpenCV, which is basically for image processing, camera data, facial recognition, and just stuff related to images. Line tracing. We'll go over that in another workshop series. And then finally, another one is TensorFlow. TensorFlow is basically for like your machine learning, your AI, your neural networks, something to consider for future. Now, close out of that. Now, I'm going to walk y'all through, as we go through the presentation, like each different section we're going over in the workshop. But first, I want y'all to open up the IDE. So I'm going to post a link in the chat. I want everyone to go to that to start up their IDE. Now, once you get there, you're going to see something similar to this. You're going to see welcome to collaboratory, welcome to or forums. I just want y'all to write or to click on new notebook. And you will be shown something like this. So right here is where you would do most of your programming, have your programming blocks and stuff. If you don't have that, all you have to do is just add code and you'll be able to code. Now, we're going to start off with the programmer's initiation. So I want y'all to type pretty much exactly what I typed. Hello world. So this is a statement, this is a print statement. Just, yeah. And now once you have that typed out, press play. And at the bottom, you will have your output. Now, everyone has now had some experience of programming. Welcome. So, pretty much every time you run, every time you type something in here, you can run, it'll run from top to bottom, line by line. And then whenever you press play, it'll have your output down here. You can clear out your output by pressing X on that icon. Now, let's go into what exactly is this statement? What is a print statement? Oh no, there you go.
Okay, yeah, so like Jeffrey mentioned, it's very simple. As you can see, it's like the simplest way to output something in a program, and you literally just type out print, parentheses, and in quotations, and then whatever you put inside those quotations is what the outside user will see. So here in the right, we have a black box, and that is what the user will see. You can basically put anything, numbers, letters, anything you want.
Yes, so going on to this first block, don't mind these green statements for now. That will be in the next slide, but pretty much you can do any phrase in the middle of your quotations. Every time you do a new print statement, one line after the other, it'll be separated by a new line, meaning this line will print on one line, this one will go on to the next, and this one will go on after. So if I run that, hello world, this is how you have to text, it'll go line by line.
Yeah, I hope everyone is following along and doing these little codings with us.
You can pretty much put most text in here, like, I don't know, robots are cool. Print robots.
Oh my God.
Yeah. And then they will print one after the other because they're two different statements, one after the other.
Okay. So after the print statements, okay, comments are very important in your programs. They're used to tell you what something does in English, and they also are used to disable parts of your program if you need to like remove them temporarily. And it's also a good way to check or reread codes looking for errors. So basically what you do is you just literally add the £. It's also called an octothorpe, a hash, and a mesh. They're like different names. I know if you're reading through like a book, they call it an octothorpe. And it's just a £, and everything after that is just commented out. The computer will not read it. It's literally just for just your own use. And so here we have an example, and it's just like, it just comments it out and it only prints whatever doesn't have the octothorpe, sorry. It's like Jeffrey will show you.
So pretty much, let's put that away. following this block right here. So now we get to see these. Pretty much if you want to make a comment, you always start it out with a hash mark, the octothorpe. Sadly, Python doesn't have multi-line comments. You're going to have to individually do that for multi-line comments. But yeah, you can, let's say you have a print statement. This is a statement. So you can have print statements. You can have them before. You can have comments, sorry. Before comment 1, you can have them after a statement. Let's just do after a statement, comment 2, and then you can have them on the same line as a statement. 3. Now this will still run the print statement, even though there's a comment right here. But if you decide to take out the line and do the octothorpe in front, you will take out the line, and now there's no output.
Then special characters in print statements. So in a print statement, special characters allow for different modifications. And here we have a couple of them, and we have some special characters within the print statements, and Jeffrey will go more into detail into each and every one of those.
Okay. Yeah, just don't mind this giant block of text. Just comments on print statements. So going in order, so in print statements, in print statements, you can start your statement with single quotes. But if you decide to put a single quote in the middle of that, it won't run. It'll run a syntax error, which just means like what you wrote down wouldn't work, basically. So how to counteract that? Backslash. You'll have the single quote. Now this will only apply whenever you have your statement in single quotes. The same also goes for double quotes. Double quotes. Yes, we will post the slides after this. So if you do the same in here, it won't print. But if you do the backslash in front, it'll print out. Now there are some other special characters, like if you want to print out a backslash. If you do that on its own, it cancels out this quotation. So instead you have to put another backslash in front of it, and it'll print out that. Now, in a print statement, you can do, like from before, to do a new line, you would just do multiple print statements. A shorter way to do that is to do the new line special character. So if I type in this statement is separated and print it out, it's not separated. Now if you do /n, it'll print this first segment into one line, and then it'll put this one into the next line. Everything after the \n will go to the next line. This statement is separated. Now, carriage return, it's been finicky for me, but if I were to go with this, pretty much how it works is in the output, this will print, right? But then whenever you do the /r, it goes back to the beginning of the statement. And then anything after the \r will overwrite whatever was put down. If this statement is shorter, this one will be partially overwritten. If this one's longer, all of it will be overwritten. Like we'll just see in here, see the statement has been rewritten. That's a different output that I had before, but okay. And now you can do tabs in print statements. Like if you're If you want to have the indent in whatever statement you want to print out, you do \T. And then is tabbed out. This will print a tab. You can put that anywhere in the statement. Like if you do that, that section is tabbed out. And yeah.
Okay, so now that you can print things with print, the next step is to learn about variables. So in programming, variables is nothing more than just a name for something. So you can use a name rather than the something as the code. So when naming variables, you cannot start with a number, but it can contain alphanumerical characters and underscores. And here we have some examples. It's also case sensitive. So Python, if you name your variable with a capital V, you have to name it throughout the whole coding, this exact same to call it on in a later line. So Jeffrey, would you like to show us?
Sure. Okay. I'm just gonna put those away. All right, now let's walk through this. So variables store basic information in Python. You can assign a variable a number, you can assign it a decimal, you can assign it a phrase. And then you can also, if you wanted to, you could just do like a single character. Right. So variable names can have letters, numbers, and underscores, but only those. They cannot start with a number and are case sensitive. The data in them can also be overridden in a later line. So as we walk through this, so legal variable declarations would be something like this: myvar _123. It starts out with a letter, and everything afterwards doesn't exactly matter. Same goes for here, where it starts out with an underscore, and everything else just kind of doesn't matter. Now this is same deal. You can put underscores, numbers, letters anywhere in your variable, but you cannot start your variable with a number. You can't start it like 123 myvar. You can't start like 5 variable. That's not legal. Now, onto the case sensitive. These two variables are different despite being spelled the same way. Now, this is all lowercase and this is all capital. Whenever you're using these in like later lines of code, later statements, you have to use what was declared here. You have to use, if you're using this first X file, you have to use the lowercase, all of it lowercase. If you're using this one, you have to use it all uppercase. And now, as it goes line by line, the program goes line by line, pretty much the latest declaration will be the most up to date. So as we go down this list, we start out W. No? We start out W at 2. So when we're on this line, A equals to 2. When you go down, it changes it to 3, and then it changes it to 4. This 4 will be what will be used after, in any statement afterwards.
So data types, here are some of the basic data types that can be stored in Python. So integer would just be the whole numbers, the float is decimals, string is just text, and boolean is strictly true or false. Python does not have a character type. I know, like, if you guys are familiar with C++, there's a char type, but Python does not need that.
Okay. So data types, you got, these are the most basic ones we'll teach for today. So you got int or integers or whole numbers. It's just like your 1s, 1 through 5, your like teens, I don't know. You got float, which is, you have float, you also have double, but for now, we'll just go with float. Float values are just decimal values or numbers with decimals in them. Strings, those are the blocks of text that you have been putting in your print statements. This right here, this counts as a string. And then you got your Booleans, or your trues and falses. We're not really going to do too much with that today, but yeah, they'll be useful for future applications.
Printing variables and data types. So the basic data types can be printed out like regular text. In the print statement, instead of printing out like the whole statement, you can just print the variable that you assigned it to, and it will just print the data inside of it. So you can have multiple variables printed in one line. And here we have an example of the basic usage of printing variables and data types. And Jeffrey will show you.
Okay, so walk through this again. You can print variables of any data type using print statements. Variables don't need to be in parentheses to print their values. So let's say you made a variable called myvar, right? You made it 2. So whenever you print it, you want to print it, all you have to do is just put the name of the variable. You don't need to put it in quotation marks. So if I were to run that, it'll print out the value of myvar, which is 2. Now on the second section, you can have multiple variables and blocks of text printed in one line. You separate each with a comma, each separated block will print out a space. So let's say you have myvar1 equals 3, myvar2 equals 4. So how this statement will walk through is it will have this block of text printed out first. Then with the comma, it adds a space into it. Then myvar1 is printed out, which will be this 3. And then comma, you add another space. And then comma, space, myvar2, which will print out 4, and then respectively. So if you run this, myvar values are 3 and 4 respectively.
So input statements. So an input statement is, you can have a user manually input data into a variable. And then an input defaults as a string, but it can be cast into another type. So we'll go over the casting in the next slides. But for now, just know that input statements are basically just what the user can manually type into the keyboard so it can read the program. And yeah, you can add a prompt for the user within the statement.
All right, now this is where the input part of the input and output. So users can manually input data into a variable using input statements. Input data can be any of the basic data types mentioned prior. So we have myvar1 declared as an input. We take an input from the user, which will show up whenever we run it. You can put anything. You can put numbers, you could put anything that you can put in a string, right? So let's say print myvar. Let's say you want to put a number into myvar1. So let's do 5. Don't mind that's third line. But now, once you've inputted 5, myvar changes into 5. So whenever you print this, this block of text would go, and then it'll change. Myvar, which is now 5, will print out. Exit out that. Oh, okay. Now you can add a prompt asking for user input by adding a string into the input statement. Just making sure. So same way we did this, but whenever you're asking for an input, which earlier it was just a blank slate and you just put in a number. So as we go through this, if you do what is your input, if you put what is your input in here, it'll output first before the user does their input. So let's say we change myvar into testing. Then like before, it'll do the print out the block, print out the variable. Yes, the variables do not carry over. Each block is its own separate thing.
Okay, so arithmetic operators are basically just your basic mathematical operators. So we have addition is just represented by an addition sign, the subtraction, multiplication, and division. The only different one is the exponent. The exponent is represented by 2 stars, and each operator can be used in declaring a variable or in a print statement. So you can use these to add variables together, and Jeffrey will show you that as well.
Okay. So basic math, yeah, you have your addition, subtraction, multiplication, division, right? You have exponent, which is a different symbol than some other programming languages, which is the double star. PEMDAS will apply to all of these calculations. So they can be used in variable declarations, like say you wanted to make a myvar1, right? PEMDAS will apply. So you do this calculation, you would get a plus 2 equals 10, then multiply that by 2, and you will get 20. Then you, for more, you do myvar equals 5, so 7 exponent 0, that will equal 1. Subtract 5, subtract from that, and then from all of that, subtract 2, and you should be getting 2. There is a modulus, but I've wanted to leave that out for a future workshop. Some people might not get the concept, some people will. So, and now, don't mind these 4, but mainly these 2. So whenever you do the arithmetic, you get your desired output and it prints out. Now, you can also do arithmetic within statements. Like for here, we're going to be doing it within these print statements. So you can, PEMDAS will also still apply. So if you did something like myvar1 plus myvar2, and then plus myvar2, right? This will still execute first, and then this will execute. So you can do that within statements, and you should get your desired outputs. Like myvar1 plus myvar2, using these, it'll be 20 plus 2, you'll get 22. Subtract, you would get 18. Multiply, you get 40. Now, in divide, you will get a decimal. Pretty much, this returns a float. These will return integers. This will return the float data type. And then for exponent, yeah.
Yeah, and like I mentioned earlier, how casting is basically just forcing another data type onto a variable. And Jeffrey can explain this one on casting.
All right. Typecasting will save you whenever you're doing inputs in Python. So usually whenever you're doing input in Python, for some reason, it usually returns a string instead of usually what you want, which is if you're going for a number, you want it to be an integer float, right? So let's just walk through this. Typecasting is used whenever you want a variable to be a specific data type. It's primarily used in specifying math calculations or string outputs. You can cast a variable in a variable declaration or in statements. So you have variable declared as the string type, which is just 5. Now, you can cast it. You can basically change this variable into an integer type. So if you were to print this out, well, I mean, all of them would be 5. But if you were to use this variable in math, instead of doing instead of like adding and subtracting strings, you'll be adding and subtracting integers. And then you can do them within statements, like you can cast after this variable declaration, after this was turned into an integer, you can turn it back into a string if you wanted to, and it'll print out. Now this is the case where Python, for some reason, whenever you're using an input statement like this one, for some reason it returns it as string. So if you did myvar equals input, enter a number, let's just go with 12, right? So whenever you do this, right, looking through this, myvar times 5, the output you want to have is the number myvar 12 multiplied by 5. For some reason, whenever you don't cast it for printing, it will multiply the string 5 times, so you get this thing, this atrocity. Now, with casting, you can specifically do actual calculations. So what is it? You do int myvar times 5, and then you'll get what you wanted, 60. So pretty much for typecasting, it's just, let's do var equals 1. To change it, all you do is, let's do var equals, you want to include the data type that you want. So let's say you want to change this into a string. You put that, and then you put the data type, and then you put whatever you want, whatever variable you want changed into a string. Same goes for integers, and same goes for floats. And now, pretty much that's all we're gonna really teach y'all, just some basic stuff, math and stuff. So, posing a challenge for y'all, I want y'all to make a very simple calculator. I want y'all to take 2 numbers as user input with a prompt. So you do the input statement, and then you put in parentheses within that statement whatever you want to prompt. And then you print every arithmetic operation between both numbers on separate lines. So the 5 that we went over, addition, subtraction, multiplication, division, and exponent, just print out each of those on separate lines. And then bonus, make the calculator work with fractions and decimals. That's where the typecasting will go in. Like if you want to have, what is it, a decimal value being output whenever you're doing addition or subtraction, you cast it to something like a float or a double. And honestly, yeah, that's pretty much it for today.